Jadi tak start recording ni? Jadi ke kan? Okay, ni start recording. Okay, so bersemangat semua nak belajar? Ke tak nak belajar lagi? Boleh belajar Boleh
Boleh.
Boleh kan?
Boleh.
Online je kan? Sambil-sambil you baring kan? Jangan tertidur pula ya? Dah makan kenyang, jangan tertidur pula. Sorry, okay, so according to our teaching plan in my notes, in my slide, so this is the old teaching plan, so I will replace its later. Sorry. So for the time being, any class material will be uploaded in Microsoft Teams, okay? Our main medium is Microsoft Teams. Please be punctual to lecture and tutorial. Pay attention to class. Get ready with pen and paper. So I have posted chapter 1 notes in MS Teams. So if you download it, you can jot down with your pen, or if you want to make it online, so or paperless, so up to you. Submit any task given on time. This is adab belajar. Okay, please be patient and so on. This is outcome of chapter 1. Okay, so by the end of this chapter, students should be able to define various measurement and instrument principle, application term and standards, explain following type of errors. Okay, it is gross, systematic and random. Use basic statistical method for analyzing measurement errors, accuracy, precision, and limiting error. Okay, so number 1 and number 2 will be covered today. Number 3 and number 4 will be covered maybe this Friday. Okay, so basically this subject contain about 50% of theory and 50% of calculation. Okay, it is different with our subject during last semester, principle of electric and electronic, because most of the content of principle of electric and electronic is calculation, right? So this subject about 50% theory, 50% calculation. Okay, so maybe for theory part, I will not explain everything because you can read by yourself. Okay, this is chapter outline. It seems like very so many subtopic, right? Okay, so see the first the first content 1.1 is theory. Some definition of instrumentation term: instrument, electronic instrument, instrumentation system. What is instrument? Device or mechanism to determine value or magnitude. So you can read by yourself, right? Electronic instrument. Okay, based on electrical or electronic principle. Instrumentation system, assembly of various instrument and other component. Okay, 3 basic function of instrument: for indicating, for recording, for controlling. Okay, for indicating, for example, oscilloscope. You can find oscilloscope in lab. Instrument with a scale and movable pointer, or maybe digital instrument, meaning that this is for indicating waveform and so on. We have screen. Recording to provide a permanent graphic record. Okay, so the second function of instrument is for recording and the other one for controlling. Measurement is a process of determining the amount, degree and so on. Standard is physical form of the unit of measurement. Okay, measuring instrument is the device used for. Okay, so you can read by yourself. All of this is introduction to instrumentation and measurement. Okay, we have two type of measurement, method of measurement, indirect and direct. Direct can be categorized into two, deflection and comparison. Comparison can be categorized into three, opposition, difference, and null. Okay. So for indirect measurement method, the unknown quantity is determined by measuring other functionally related quantities and calculating the desired quantity rather than measuring it directly with an instrument. So it requires formula. For example, we want to find resistance. So a resistance of a conductor may be determined by measuring voltage across the conductor V and current flowing through the conductor I, and calculating by Ohm's law, meaning that we want to find R. So we measure the, let's say we want to find resistance across a conductor or a resistor. So we measure the voltage through the conductor. Okay, the example here is conductor. We measure the voltage through the conductor, and then we measure the current through that conductor. Okay, the current flows through the conductor. Then by using Ohm's law, we calculate the resistance. So this is indirect, meaning that we are not directly measure the R, but we find V and I, and then we calculate R by using Ohm's law. So please give me a formula of Ohm's law. The original formula of Ohm's law.
V equal to IR.
Andai. Siapa tu? V equal to IR. Okay, so R equal to V over I. Okay. Oh, semangat. Okay. We continue. Okay, R equal to V over I, derived from Ohm's law. Okay, the next is direct measurement method. Okay, the unknown quantity is directly compared against a standard. The result is expressed as a numerical number and a unit. Okay, so direct measurement can be classified into two, deflection and comparison. Deflection is quantity, the unknown quantity is determined by means of measuring instrument, okay, having a scale. So the instrument has needle, for example, or has a digital scale. So it will, so deflection for analog. Let's say we have ammeter. When we measure current through a conductor, so the ammeter will show deflection, and then we just read the measurement. Comparison method, the unknown quantity is determined by direct comparison with the standard of the given quantity. It is applicable to quantities that can be reproduced by standards. Anak ayah dekat depan dia kata, "I laju ni cakap." Laju ke? Laju ke? Am I too fast? Takkan? Because boleh tahan. Because okay, if you have question, then you can interrupt me. Do not wait until the end of the class. Okay, tapi tak mengapa. Because all of the beginning part of this chapter is theory. Okay, so when we come to calculation part, I will explain to you one by one. Okay. So when I explain quite fast, meaning that I know you can go through by yourself. Don't worry ya. Okay, anak I risau, anak dekat depan ni. Dia form 2, so belum masuk sekolah lagi. Kena bawa sini. Okay, comparison. Okay, we have three types of comparison method: opposition, difference, and null method. Okay, for opposition method, in which two quantities, the measured quantity and the quantity reproduced by the standard, act simultaneously on a comparison device. So, difference method is between quantities acts on a comparison device. Null, resultant effect of the comparison is zero. So for null method, it associate with zero value. Okay, that's how we call it as null. For example, in measuring resistance by means of a DC bridge with complete balancing. So you will understand better the null method when we learn chapter 5. I think chapter 5. Okay, it is DC bridge. Okay. Because we will go through in detail the null method. Null measurement is measuring current and voltage more accurately by balancing the circuit. So in null method, we balancing the circuit and we will find the current. We will make sure that current is zero so that no current flows through the measurement device. So today you will get the idea. Okay, maybe you can understand well, but we will go through in chapter 5. Okay, inshallah, in chapter 5 you will understand better. Okay, so in null measurement method, no current flows, then the circuit is balanced. Okay, so we will make sure that there is no current flow so that the device or the circuit will be balanced. Standard measurement of voltage and current alter circuits introducing numerical uncertainties. Voltmeters draw some extra current, whereas ammeters reduce current flow. Null measurement balance voltages, so there is no current flowing through the measuring device and the circuit is unaltered. Null measurement are generally more accurate. Okay, so null measurement method is generally more accurate but more complex. Okay, we will go through it in chapter 5. Their precision is still limited. Okay, this is null method. Suppose you wish to measure the EMF of a battery. So this is a battery. The voltage of the battery is EMF. Okay, EMF is for battery. Consider what happens if you connect the battery directly to a standard voltmeter. So this is standard voltmeter. Pointer. Okay, so this is voltmeter. Okay, V. This is voltmeter. The positive voltmeter connected to positive battery. The negative voltmeter connected to negative terminal of the battery. Consider what happened. Okay, if we connect a voltmeter directly to a battery. Okay, the actual quantity measured is the terminal voltage V. Okay, which is related to the EMF of the battery by V is equal to EMF minus IR. Okay, if we apply, okay, what principle we apply in the loop? What principle? If you look at this equation, so this is referred to what? Anyone want to answer? This is the principle of what?
KVL.
Yes, Kirchhoff current. Siapa tu? This is KVL, okay? The summation of voltages in a closed loop is equal to 0. So actually, if we write equation, okay, let's say we start with the second sign of voltage. Okay, so you will write like this: negative V, right? And then this is positive, right? This is negative, so this is plus IR, right? IR and then plus what we call this, EMF equal to 0, or we can write like this, V is equal to EMF minus IR. So this is positive sign here, negative sign here. Okay. Positive here and negative here. Nak masuk kelas tak accept lagi. Wait ah. Faris. Okay. I will ensure that only my student are in my MS team, okay? Okay. Okay, can I understand this? So V equal to minus IR. IR is the voltage drop across this internal resistance, and then plus minus here, positive here and minus here. Okay, so this is the equation. So where R is the current that flows and R is the internal resistance of the battery. So I think this one, you have found this one last semester, right? In subject principle of electric and electronic, right? So you learn about internal resistance of the battery, right? Isn't it? Betul tak?
Yes, doctor.
Kan? Still remember? Ingat lupa? Still remember, right? The EMF could be accurately calculated, okay, if R were very accurately known, but it is usually not. If the current I could be made 0, okay, then V is equal to EMF, okay. So if current is equal to 0, if current is equal to 0, so this portion will be 0, right? So V is equal to EMF. And so EMF could be directly measured, okay? Remember that we want to know the actual value of the battery. So if this portion will be is 0, so we can know the value of the battery, voltage of the battery, because the voltmeter will directly measure the EMF of the battery, okay? However, standard voltmeters, okay, this is voltmeter, need a current to operate. So we cannot make the current is equal to 0. So another technique is used. Okay. So that's why we use galvanometer. Okay. So this is galvanometer. It is electromechanical instrument for detecting and indicating electric current. So if you can see the middle scale of this galvanometer is 0, okay? So potentiometer. This is potentiometer. potentiometer. Okay. This is adjustable variable resistor. Okay, with 3 terminals. This is the real picture of adjustable resistor. Okay, we have 3 terminal. The location of the contact is adjusted until the galvanometer reach 0. So, how to make current equal to 0 in this circuit? We will put the galvanometer here. We will adjust this galvanometer so that currents will indicate 0, meaning that we give the 0 current to this circuit, and then finally we can know the real EMF of this battery. Understand or not? Can I understand? Philly, understand?
Yes, doctor.
Okay, so okay, that's why I show this circuit, because in null method null is 0, right? So this is the approach to make the value to be 0. Okay, 0 value. So in this circuit, in this example, we use galvanometer. The principle of galvanometer is to read 0. That's why the middle scale of this galvanometer is 0. Okay, so if the needle is deflect to the right or to the left, so meaning that there is current. Okay, there is a value of current. There is current in the circuit. Okay, so how to make the current equal to 0? We adjust the variable resistor. Okay, so R equal to V over I, right? Okay, so if R is high, the current is low, right? So we will adjust R until it deflect to 0, meaning that there is no current in the circuit. Okay. So this is a picture or summary of measurement method. This is for deflection. Okay, we just read. This is the measurement. A is the measurement. Okay, so the measurement value of A is here. Okay, this is the measurement. So this is difference. The pink. Okay, the pink. The highlighted pink is the measurement. Okay, so it is A is here minus R. This is null method. Okay. Okay, so the SI unit has been covered during your secondary school, matric, or diploma, right? Okay. Okay. SI system international. Okay. So consists of 28 units, 7 base units, 2 additional units, and 19 draft units. Base unit. Okay, this is base unit. Length, mass, time, temperature, luminous intensity, electric current, and so on. Okay, so make sure during your final exam, test, quiz, and assignment, please do not leave the unit. Okay, the unit of each quantity. Okay, let's say it is length, so make sure you put meter or kilometer and so on. If it is current, so make sure the final answer you must write M. Okay, M. Dimension. Okay, so you can read by yourself. Dimension of velocity, acceleration, and so on. I think this subtopic has been covered during your secondary school and so on. Velocity, you know all the formula, so I think no need to explain. Standard of measurement. As the measurement is a process of comparison, therefore, regardless of any measure method, basic of comparison must be employed. Okay, standard of measurement is defined as physical representation of a unit. Okay, let's go fast. There are 4 categories of standard: international, primary standard, secondary standard, working standard. Okay, this is the explanation of international standard, primary standard, secondary standard, working standard. This is the summary. Okay, so we go to the summary. International standard is international agreement, and they represent certain unit of measurement to the closest possible accuracy. Okay, Bureau of Weight and Measures in Paris. It is the owner of the international standard. It is applied for work at the level of work worldwide, not available to ordinary user. For primary standard, calibrated independent by absolute measurement at each of the nation. Okay. For verification and calibration of secondary standard, for example, SIRIM. Okay, it is national institution not available to an ordinary user. Secondary, used by measurement and calibration laboratories in the industry. Okay, so this is for industry. Working standard used in lab. Okay, day-to-day basis. For example, standard resistor, capacitor, and so on. Okay. Okay, any question up to here? Very basic.
No, doctor.
Okay, very basic, right? Internal resistor of galvanometer. RG tu apa? Okay. Resistor dan galvanometer. Yes, RG is the resistance of the galvanometer. Okay. Bonaventure. How to pronounce your name? Bonaventure Lo Guangyi. Bona. Okay. Bona local student or international student? Local, okay. So your hometown is where? Kampung kat mana? Negeri Sembilan. Negeri. Pandai cakap negeri ke? Mantin. Bona, can you speak Negeri Sembilan? Slang. No. Okay. SI electrical unit. So all of these have been covered during secondary school. Okay, and your last semester as well. Current, voltage, resistor, inductors, and capacitance. Anak I ni. Pesan jangan bising. Shh. Okay, current is the quantity of electricity charge that passes a given point in a conductor during a time of 1 second, or the time rate of, or we can define current is the time rate of change of charge. So current is equal to Q over T. Q is charge. Okay, unit of current is ampere. Unit of charge is coulomb. 1 coulomb is equal to this number. So no need to memorize this number as we are facing online learning. You can refer to your notes. Okay. This is for voltage. Voltage is the potential difference, okay, between 2 points of a conductor. So imagine that this is a conductor. carrying a current of 1 amp when the power dissipated between this point is 1 watt. Voltage is the unit of electromotive force and potential difference. So EMF is for battery, okay, or for voltage source. Potential difference is for other element, right? Okay. So both element, both parameter, okay, EMF and potential difference use voltage as its unit. One joule of work is considered done when 6.24 multiply 10 to the power of 18 electrons are moved through a potential difference of 1 volt. 1 electron carries a charge of this number. When only 1 electron moves through 1 volt, the energy known as electron volts. Okay. EV is used in the case of very small energy level associated with electrons in orbit around the nucleus of an atom. So this one covered last semester, right? In subject Principle of Electric and Electronic. Chapter apa? Diode. Semicon, right? Okay, now resistance standard. Ohms is defined as the resistance which permits a current flow of 1 amp when a potential difference of 1 volt is applied to the resistance. So R is equal to V over I. This is Ohm's law. V equal to IR. Okay, unit of resistance is ohm. Okay, this is inductance standard. Unit of inductance is Henry, H. The inductance of a circuit is 1 Henry when an EMF of 1 volt, okay, EMF from the battery is induced by the current changing at the rate of 1 amp per s. So when current flows, okay, through a conductor, through a inductor, so we call it as inductance. We have some elements associated with inductance such as Weber magnetic flux density. Okay, magnetic flux density, the unit is Tesla. Magnetic flux is Weber. Defined as the magnetic flux which linking a single coil. Okay, magnetic parameter. Okay, will be you will learn all about magnetic characteristic in subject, I forgot, but in year 2, okay, in year 2. So you will go through very detailed the parameters of magnetic, okay, the calculation of magnetic. Okay, so this part just want to introduce the resistance, the capacitance, inductance, current. Capacitance standard unit is capacitance. Okay, farad. The farad is the capacitance of a capacitor that contains a charge of 1 coulomb when the potential difference between its terminal is 1 volt. So this is capacitor. A capacitor has 2 plates. Okay. This is 2 plate. Okay, 1 and 2 plate. Okay, so when the potential difference between it is 1 volt, the charge is 1 coulomb. C is equal to Q over V. 1 farad is equal to 1 coulomb over 1 volt. Okay. Okay, this is about performance characteristic. Okay, it is about performance. Okay, for example, accuracy of measurement, precision of measurement, resolution and sensitivity of measurement. Okay, it is important to because it allows you to select the most suitable instrument for a specific measuring jobs. Okay, basic characteristic two, static and dynamic. Okay, static measure constant process condition, dynamic measure varying process condition. Okay, all these terms, I'm sure that you are familiar with all of these terms, accuracy, precision, resolution, but we will go through a bit detail in this chapter. Okay, this is accuracy, the degree of exactness or closeness of measurement compared to the expected or the desired value. Okay, so meaning that measurement versus actual or expected or true value or actual value. Okay, closeness of the instrument output to the true value of the measuring quantity. So relative accuracy is equal to 1 minus this. This is yn is expected value. This is measurement value divided with expected or divided with actual or divided with true value. Okay, so the percent is times 100. Percent of accuracy is 100 minus percentage of error. Okay, this is precision, measure of consistency or repeatability of measurement. Okay, the formula is 1 minus this. This is value of n instrument minus the average divided with the average. Okay, this is low precision. Why? Because each reading are not close, right? This is high precision. Why? Because all of the readings are very close to each other. Accurate because it diverge to the at the middle. Precise because all the measurement are close each other. It's accurate and precise. This is neither accurate nor precise. Resolution, the smallest change or interval in a measurement variable to which an instrument will respond. Sensitivity, ratio of change in the output or instrument to a change of input. Expected value, the design value or the most probable value that expect to obtain. The expected value is the we call expected value is same as actual value, is same as true value. Okay, error is the deviation of the true value from the desired value. Desired value. Okay, so this is resolution. If you look at the DC voltage range, you have, okay, this is the scale. We have 500, 200, 20, 2000 milli or 2 volts, 200 milli. Okay, so choose the setting that is higher than what you are measuring and the closest. If you are going to read 1.5 volt battery, okay, so from your calculation, the battery or the voltage source should be 1.5 volts. Okay, but you want to measure. Okay, you want to measure. You want to confirm the value of the battery. So you would choose 2 volts. Okay, 2000 millivolt is equal to 2 volt. Okay, because it is closer to 1.5 volt. It may read back something around 1.567. Okay, because 2000 milli. If you choose to 20 volt, you will instead get 1.57. For example, okay, it is still correct, but you don't have the precision. If you choose 2000, you will get 1.6 maybe. So choose the smaller value that is greater than your target. Okay, the next subtopic is okay, we are still in static performance characteristic. This is error. Okay, type of error: gross or human error, systematic and random error. Okay. Okay, we know that generally no electronic component or instrument is perfectly accurate. Okay, it will have some error or inaccuracy. So it's very difficult to define the true value. There is always some difference, okay, between the measure and the true value. So absolute error is the difference between the expected and the measured value. Okay, meaning that the difference between the actual or the expected or the true or the actual value with the measurement. Okay, error may be expressed either as absolute or percentage. So this is absolute percentage is just divided with the actual or expected value multiplied with 100. Relative accuracy, 1 minus error. Okay, 1 minus this portion. Percentage of accuracy is 100% minus with the percentage of error. Precision is, okay, this is the formula. Okay, this is the example. Given the expected voltage value across a resistor is 80 volt, meaning that this is from your calculation. Okay, from your calculation, it is expected 80 volt. The measurement is 79. So calculate the absolute error. Absolute error, okay, it is the difference between the expected or the true or the actual with the measurement. So 80 minus 79. 1 equal to 1 volt. Okay. In absolute error, you can just ignore. Okay, nak cari word tu. You can just ignore the negative value. You just find the difference. Okay, you make it absolute. Modulus. Okay, modulus. The percentage of error. Okay, that value 1 volt divided with the actual or expected or the true value or the calculated value. Okay, multiply with 100. So the percentage of error is about 1.25%. Relative accuracy is 1 minus 1.25. Okay. Dapat tak? 1 minus 1.25. Oh, sorry. Okay, so not in percentage. Okay, so 1 minus this portion. Okay, not in percentage. And you will get 0.98. So relative accuracy, the value is from 0 until 1. Okay, must not more than 1. Okay, percentage of accuracy. So just 100 minus the error. Okay, any question? Any question?
So far.
So, okay, because very easy. Very easy. Okay, I tell you the most challenging part in chapter 1 is limiting error. Okay. Okay, so this is chapter 1 outline. We have covered 1.1 until 1.4 and then 1.5, 1.6 now 1.7. Okay, types of error. Okay, 1.7, 8, 9. Statistical analysis also today. Okay, 1.11, 1.12 the most challenging part in this chapter. So this Friday we will learn limiting error. Okay, we will learn limiting error. So please pay your attention. Okay, the challenging part in the hardcore in this chapter, limiting error. Okay, summation of error is it is on actually it is a subtopic. Okay, limiting error. In limiting error, we have summation of error and so on. Okay, so please pay attention during the subtopic. Okay, now we are learn about statistical analysis. So it is very easy, very easy. Don't worry, very easy. Okay. Apa ni? Okay. Okay, this is another example. So you can find you can find more example in tutorial. I forgot to upload tutorial. Okay, later after this class, I will upload tutorial 1. Okay, you should try yourself. I will provide answer or not. Okay, I'm not sure. You will try yourself, and if it is not enough, you can find more example in textbook. Okay. What textbook? Please refer to our teaching plan. Refer to our teaching plan, page 1. This is references for this subject. Okay, you can find this book maybe online or in library and try the examples from this textbook. Okay, the expected value of the current through a resistor is 20 milliamp. So meaning that this is measurement or calculated or expected true value. What? Measurement or true value? Please answer. The expected, right?
Yeah,
20 milli. 20 milli is the expected. Okay, the expected. Or we call it as the true value or the actual value or the calculated value. Okay, the measurement 18. Okay, so there are difference between the measurement and the calculated or the expected. Calculate the absolute error, percentage of error, relative accuracy, and percentage of accuracy. So please don't worry. You can refer to your notes. You can refer the formula from your notes when you are sitting your final exam and so on. Okay, but you have to understand how to use the formula. How to calculate the absolute error? Just difference between measurement and the calculated or the expected. So 2 milliamps. Okay. Percentage of error is the error 2 milli divided with the expected. It is 20 milli multiplied with 100. Okay, so the percentage of error is 10%. Relative accuracy is 1 minus this portion. Okay, do not multiply with 100. Okay, so bear in your mind that relative accuracy is the value is from 0 to 1 only. Do not exceed 1. And then accuracy is 100 minus percentage of error. We get 90%. Okay, this is other example for precision. From the value given in table 1, calculate the precision of the 6th measurement. The 6th measurement is 100. Okay, so how to find the precision? This is the formula 1 minus this. Xn is the measurement of particular measurement. It is 100. Okay, minus this is the average. divided with the average. So we have to find the average value first. How to find the average value? Just summing all the values in the measurement, okay, divided with 10 reading, right? This is the average, okay? So the precision of the 6 measurement is, referring to this formula, 1 minus xn is 100 minus the average value divided with the average value. So this is the precision of the 6 measurement. Any question?
No, doctor.
Okay, very easy, very easy. Type of error, we have gross, systematic and random error. Gross error is, we call it as human error as well, because it caused by human mistakes in reading or using instrument. May also occur due to incorrect adjustment of the instrument, and okay, so you can read by yourself, right? Very easy to understand, cannot be treated mathematically, cannot eliminate, but can be minimized. Why? Because of improper use of an instrument. Let's say, okay, so this error can be minimized by taking proper care in reading and recording measurement parameter. In general, instrument change ambient and so on. So the solution is take several readings, at least 3 readings, okay, to minimize the effect of ambient condition changes. Okay, so you just understand that gross error is human error, okay? So anything caused by human error. And the solution is take several readings. Example of reading resistor value using multimeter. Oops. Okay, systematic error or technical error. Systematic is technical error due to shortcomings of the instrument. Okay, so gross error is caused by human. Systematic error caused by technical error. It is due to shortcomings of the instrument, such as defective or worn parts, aging, or effects of the environment and on the instrument. Okay, so there are three types. Instrumental error, environmental, observational error. Okay, so you can read by yourself. It is caused by inherent while measuring instrument because of their mechanical structure, for example, improper calibration of faulty instruments, friction of the barrier and so on, irregular spring tension and so on. How to avoid proper maintenance, select a suitable instrument for the particular measurement application, apply correction and so on. Okay, environmental error due to external condition, how to solve. For example, use aircon. Okay, so let's say, okay, question asks you in final exam regarding this error. So I can accept any acceptable answer. Okay, not necessarily exactly the same as in your notes. Okay, but you can use your own word. Observational error introduced by the observer. For example, parallax error. Okay, parallax error. You know what is parallax error, right? Okay, you have learned it during your primary school. It's not secondary school. Okay, parallax error, right? This is parallax error. Okay, random error. Random due to unknown causes. That's why we call it as random error. Occur when all systematic error has accounted. Okay, or it is accumulation of small effect. How to avoid increasing number of reading? Okay, the same solution. Use statistical method to obtain the best approximation of true value. Okay, this is the summary of error in measurement. Okay, this is previously we learned about static. Okay, performance characteristic, static, right? So this is dynamic. You can read by yourself. Measuring a varying process condition. Okay. Can read by yourself. The dynamic behavior of an instrument is determined by subjecting or forcing its primary element to some unknown and predetermined variation in the measured quantity. The three most common variation in the measured quantity: step change, linear, sinusoidal change. Okay. For example, in step change, the primary element is subjected or forced to an instantaneous or finite change in measured variable. Okay, the dynamic performance characteristic of an instrument: speed, dynamic error, lag, fidelity. Speed of response, the rapidity with which an instrument responds changes in measured quantity. Okay. Dynamic error, the difference between the true and measured value with no static error. Okay, so our instrument should have this characteristic. Okay. For example, no delay in the response of an instrument, and fidelity is faithful or reliable reproduction. Okay, this is statistical analysis. I think some part in statistical analysis has been covered previously. Okay, for example, arithmetic mean. Okay, so I'm sure you know what is arithmetic mean. It is average. Okay, so the summation of all readings divided with number of reading. The deviation is the difference between each piece of test data and the arithmetic mean, meaning that D1 is equal to that reading, okay, S1 minus average. Okay, this is deviation, meaning that the deviation or the difference between each reading with the average of the reading. Average deviation is the summation of all deviation divided with number of sample. Okay, express the precision of the measuring instrument. A low value of average deviation indicates a precise instrument. So a good or a precise instrument has low average deviation. Okay, same goes for standard deviation. This is the formula for standard deviation. Each deviation, okay, is kuasa 2 apa? Square. Okay, square. Sum all the square value of each measurement, okay, multiply with n minus 1. Okay, so please emphasize on this, n minus 1, not n. Okay, and then square root. The degree to which the value vary about the average value. So a good measurement has low standard deviation, low average deviation, low deviation. Okay, because deviation is the difference between each measurement, each reading with the average. So meaning that it is precise. Okay, so each measurement is close to other reading in that measurement. Faham tak? Okay, this is example. The data from capacitors measurement. The reading is in microfarad. Calculate mean, not mean but MEAN. Okay, this is MEAN. Kan. Deviation, standard deviation, average deviation. Okay, no answer here, so you just calculate by yourself and you compare your answer with your friend. Okay, very easy. Okay, this is another example. Number 1, calculate arithmetic mean. It is average. Okay, so just sum all the readings divided with 5. Okay, because we have 5 reading here. And then this is the average or arithmetic mean. Number 2 is deviation of each value. So you just get difference between each measurement with the average. Okay. So 49.7 minus the average. 50.1 minus the average. Or the release minus the average, and you will get the deviation. Okay. So you can just take the absolute or the put modular sign. Okay, you can ignore the negative sign. You can make it positive or you can make it negative. Okay, and then what else? The algebraic sum of deviation. You just okay. So usually we are not asking on algebraic sum of deviation. Usually we ask on a standard deviation. Okay, so in standard deviation or in average deviation, okay, we take the absolute. We ignore the negative sign. Same goes for standard deviation where we square each d. Okay, you will get positive, right? If it is negative, you will get positive. Okay, this is the challenging part in this chapter. We will learn this Friday. Okay, if I teach you today, I think dah apa? Dah tepu, dah apa? Full. Right. Am I right? Because you need to pay high attention in, yes, you should pay your best attention in limiting error subtopic. Okay, so let's learn it during this Friday. Now let me take your attendance. Okay, from here download attendance list. Okay, and I will, yeah. Okay. Any question? You can ask anything from the first slide until this slide. Okay, you can ask anything. Any question before we end our session? Even though you think that it is stupid question, just ask. Okay. Because during your quiz, midterm test, final exam, you cannot ask me anymore. If you want to ask now. No, no question, right? Cuba cakap tak ada. No question. No. Any question?
No.
Macam tu.
Ada.
Akif no.
No, min.
Bagus. Siapa ni usik ni? Akif. Okay. No question. Okay. So if there is no question, I will stop recording. Stop.